Another example for constraint motion. In this problem, we have two masses A and B. They are sliding on these two rods, and they are connected together with this cord with the constant length of L, which is straight, and it's going to remain straight all the time. And we are showing the location of these two particles with X and S. Velocity of A in this direction is going to be X dot. X increases, so velocity of A is going to be in that direction if X increases. And if I define the velocity of B in this direction, I mean, assuming this direction is positive for this velocity, this is going to be equal to negative S dot, right? Because when S decreases, it means B is moving in this positive direction. So S is going to be negative, velocity of B is going to be negative S dot. If I consider that direction, the other direction, as the positive direction for velocity of B, then VB is going to be just positive S dot. It's your choice. But the problem here is it says consider velocity of B to be equal to negative S dot, which means we are considering this direction as the positive direction for velocity of B. Now the question is asking how we can write the velocity of B in terms of X, S, and velocity of A. So to solve this problem, like the previous problems, I need to relate X and S together. Then after relating them together, I can take a derivative of that constraint equation to find the relationship between the velocities. So how can I connect these two together? In this triangle, L is going to remain constant. And also this angle, which is 135, is going to remain constant all the time. And I can write the length of L in terms of X and S using cosine law, which is quite simple. L squared, based on cosine law, L squared is going to be X squared plus S squared minus 2 times S times X times cosine of 135, which is negative root square of 2 divided by 2. So now after having this, the only thing I need to do is taking derivative from this constraint equation. If I do that, I'm going to have 0 here. In the other side, I'm going to have 2x x dot, 2 times x, and x dot is velocity of A, plus 2 times s dot, and s dot is negative velocity of B. So I'm going to have negative 2s velocity of B. And for this one, I'm going to have negative 2 times x dot, which is VA, times S, times cosine of 135, which is negative root square of 2 divided by 2. Then minus 2x S dot, cosine of 135. So I'm going to have negative 2 times x, and S dot is negative VB, times negative square root of 2 divided by 2. So that's almost all. Now we are relating velocity of B to A in this equation. If you just clean it up and rewrite it, you're going to have velocity of B is going to be equal to S plus square root of 2 times X divided by X plus root square of 2 times S, all times velocity of A. So in this equation, we have the velocity of B in terms of VA, X, and S.